Hi everyone, I'm Doug Black, Editor-in-Chief at Inside HPC, and today we're at the ISC conference in Hamburg, and right now with us is Rick Koopman. He is Director of HPC and AI, EMEA, Emerging Markets. Rick, welcome. So today, we know a major theme for Lenovo these days is sustainability. What updates can you give us on how customers are leveraging Lenovo HPC solutions to become more sustainable?
Okay, so one of the things that you see straight behind us already is the new introduction of one of the largest ever announcements that we've done in our history of new water-cooled technology. It's water-cooled technology for both accelerator workloads and for CPU-based compute workloads. The entire goal of the principle of direct water cooling is very optimized heat management. So get heat away from the computational parts as efficient as possible. So we've introduced water cooling already more than a decade ago. Started using warm water cooling with water of up to 50 degrees Celsius to cool down the compute nodes. We're using copper, as you can see, nice and shiny, but not only because it's nice and shiny, because it's also very efficient from a water transportation perspective and heat dissipation perspective. So cooling with water is about 4,000 times more efficient than cooling with air. So the heat transfer to air is about 4,000 times less efficient than heat transfer to water. So with that, you can reduce the heat dissipation in the data center tremendously and optimizing the PUE of your data center to values below 1.1 instead of around 1.4.
That's tremendous. I've written about your water cooling Neptune in the past. I was very impressed that you actually cool systems with water that's about 120 degrees Fahrenheit,
Yeah.
which is about as hot as the water when you take a shower. So cooling,
it's even hotter,
yeah. So cooling systems with hot water, amazing.
Yeah, so as long as you make sure that the delta between the water temperature and the maximum temperature that the junction temperature of your processors and your GPUs can be, you're always cooling down. And we base the flow rate of the water going through the plumbing and the piping, we base it on the type of processor that is in there, the TDP value of the processors, the TDP values of the GPUs, and the type of workload you're deploying to make sure that there's enough water flowing through the copper to cool down the heat dissipating component. So it's not only the processors, of course, it's not only the GPUs, it's also the memory DIMMs, it's also the voltage regulators. Yeah? Voltage regulators are little stoves in a compute environment. They create a lot of heat because they're doing the conversion of power into the power that you need to operate a compute node. So we're cooling everything, and you need a temperature that cools down the processors enough. You don't have to cool them down to 20 degrees Celsius or anything, just enough so they operate at the optimum temperature.
Yeah, and my understanding too is that one thing that distinguishes Lenovo water cooling is it's very comprehensive within the board. Is that the case?
It basically is an isolated real ecosystem behind the primary water facility of a data center. So what we basically built with the customer based on the architecture definition of the overall solution is we size what is going to be needed based on the temperature of the water, based on the ambient temperature of the data center, and based on the air cooling capacity that they still are willing or able to use. Based on that, we determine what type of CDU we need and what the flow rate should be for the water to flow through it. And again, this is water flowing through it, so it's not a glycol mixture or anything. It's water, it's demineralized water. And we're the only ones that are using demineralized water, so non-toxic liquid in our closed ecosystem. And 50 degrees Celsius was a temperature we selected for a reason. When it comes out of the loop after cooling down everything, it's 62 degrees Celsius. That's a temperature where you efficiently can do something with the water, like floor heating on a campus, like using warm water as input into a reverse heat pump mechanism to create free cold water for that little bit of air cooling that you still need in a data center. So it is a comprehensive proposition that we have, and it helps our customers reduce the carbon exhaust that they have tremendously.
Excellent. Now, what innovations and new offerings are you bringing to market right now, and what's in it for clients?
So the innovations at this moment with the new generation is optimizations, adoptions of new accelerators, adoptions of new processors in the form of Genoa and in the form for AMD and in the form of Sapphire Rapids. So all the top-end SKUs from a processor perspective, so with TDP values of scaling up to 400 watts when you're running HPL per processor, are supported completely within the system. H100 GPUs are being supported already from day one in our water-cooled solutions. NVIDIA H100 GPUs, they have a TDP value of 700 watts. You have 4 of those monsters in a 1U tray with 2 400-watt processors. So you're reaching the 3 kilowatts on the 1U boundary with the new technology. So what we also did was we improved again everything we have from a cooling perspective, the flow capabilities through the system. We optimized the flow again to have the cooling of the processors isolated from the cooling of the memory DIMMs and the voltage regulators to make sure that the delta T between the two processors is never going to be higher than 5 degrees Celsius. Because you don't want to have thermal differences between the two processors that are one in the same node. You want to have consistency when you're doing computational work. That's a lot of the improvements that we've done here.
Okay, so what sets Lenovo HPC apart from the competition?
The main thing for me really is that we didn't start this Sunday. We've been doing this already for more than a decade. We started with this when we were still IBM. So we're doing that for more than a decade. We are the company in HPC that has the most experience with cooling technologies, with water cooling technologies. That's one thing. The second thing is that we decided already 10 years ago to use water internally in our secondary loop. So in the cooling loop behind the CDU. So the cooling loop that we build with the customer, that we deploy with the customer, that we install for the customer also. So we're doing the plumbing and the piping as part of the engagement. We don't leave it to a third party. We have specialists in our professional services team that does the CDU installation, that do the plumbing and the piping under the floor, that connect to the primary water loop, and everything that's needed from a plumbing and piping and connectivity perspective. The main thing that differentiates us is the water. Again, we started with that already 10 years ago. It is demineralized water. It's not a glycol 25% mixture like you see very often in the cooling environments. The plumbing and the piping that we have internal of the nodes, completely copper. Efficiency from the flow perspective, thermally efficient. We are not using fab in the nodes. We don't want to use plastic in the nodes. Plastic, when you heat it and you bend it in the corners that you need, gets thinner on the outside. So you get hair fractures, you get leakage. We don't want to have any leakage in a data center. And I'm very happy to say that we haven't seen any issues with the copper side of the house once we have installed it. So copper, water are the two main reasons why I think we are very successful with this, and market adoption also shows that we're very successful with this, and the efficiency that we create now. So the efficiency now adds up to, including the water-cooled power supplies, adds up to 98%. So 98% of the heat generated within the computational node is transferred to water. 2% we can't get rid of. And that's science. It's called radiation. Metal that gets warm radiates heat, and you can't cool that with an internal copper loop. So for getting rid of those 2%, we very often add some form of grid or heat exchanger or something to get rid of that 2%, to get to approach really 100% efficiency, 100% heat transfer to water, which basically means you don't need cracks in a data center anymore, you don't need chillers in a data center anymore, you don't need the noise of the fans, you don't have hot air blowing around anymore. It's silent. You could do an executive meeting in a data center.
Very good. All right, great stuff, Rick. Thank you so much. We've been with Rick Koopman of Lenovo here at ISC. Thanks so much.
You're welcome.